This video shows you how the Si9000e projects option extends the graphing capability to allow you to model a range of different scenarios that you couldn't do with a standard Si9000. And for this particular illustration, I'm going to show you how to graph insertion loss whilst changing trace separation but holding the impedance constant at 100 ohms. If you're familiar with the standard Si9000e, it allows you to graph a single structure with given dimensions over a range of frequencies. Adding the project graphing capability allows you to sweep one or two physical dimensions, and it makes it very easy to look at a number of scenarios as you change different dimensions over a wide range of frequencies. So adding the projects option allows you to plot frequency-dependent characteristics on a single structure with multiple dimensions. Or you can do multiple structures with similar dimensions. The only limitation is your curiosity and imagination. So for this example, I'm going to take a differential strip line and sweep the trace separation while holding the impedance constant by adjusting the trace width. So this is the Si9000 standard sensitivity analysis, and I'll focus in here, varying width 1 and width 2, and sweeping S1 from 30 to 300 microns, holding a 100 ohm differential impedance. So where do you start in graphing this scenario? First, you'll run a sensitivity analysis and then automatically populate a project file, and you can store the project as an SIP file and recall it for use later on. So the very first step is to select the structure and calculate the impedance. In this case, I'm going to choose a differential edge-coupled offset strip line and select 100 ohms and solve for 100 ohms. Next thing to do is to set up the frequency dependent tab, and in this case, once I've got the frequency dependency, I want to go and look at the maximum frequency and run from 500 megahertz up to 40 gigahertz. And I'm going to choose Hure surface roughness. You can see there's a range of smooth surface roughness compensation from smooth, Hammerstead, Croix, gradient, and Hure. Now switch to the sensitivity analysis tab and set up choosing sweeping S1 from 30 to 300 microns in 30 micron steps. I now want to do that by sweeping the trace width and holding at a constant target impedance of 100 ohms. Click Calculate, and then the field solver will run multiple times and set up the project for you. So there's 10 results. Just to recap, you can see the width and the trace separation that's been adjusted to achieve the constant 100 ohm differential impedance as we sweep through those dimensions. This is where you save time. You can create project structures automatically. So you right click in the results area and it now creates 10 project structures with the appropriate dimensions calculated in the sensitivity analysis. The next step is to right click on any of those structures and select graphing. And what this will do is solve for each structure in turn and generate the insertion loss graph and overlay it on the final graph for comparison. So it runs a number of times to complete all the graphs you require and then delivers you all of those solved results on one single graph. So in summary, the graphing option for SI projects provides useful plots to contain data from multiple structures. There are numerous uses for this type of option, comparing the impact of different dielectric materials, different roughness, sensitivity analysis for insertion loss calculations, and more. If you'd like a PDF version of this content, please check out the polarinstruments.com website and search for Application Note AP8208. Thank you for watching this video introducing the Si9000e project option and some of its powerful graphing capability. If you'd like further information or an evaluation of Si9000e with the project option included, please do contact your local office and they will be delighted to assist you. Here's a list of key contacts and phone numbers. Thanks again, and I look forward to any suggestions you may have for more Polar videos.